Okay, colleagues, we've got this question which says, let Z follow our standardized variable, follow a normal distribution with the mean, which is 0, and the standard deviation 1. Okay, colleagues, this is what this notation means. Okay, so this question is just about calculating probabilities. Okay, colleagues, it's all about calculating probabilities. Okay, so if you see a Z, okay, it means your variable has already been standardized. Whatever you're measuring has been standardized. Okay, you can measure various things: eye color, height, weight, all of these things. If you see an X variable, because this type of question sometimes you will see an X instead of a Z. If you see an X, it means your variable hasn't been standardized and you need to standardize it. But in this case, since there is a Z, since there's Z, we can see Z's here. It means it's been standardized for you. You just need to read the probabilities. Okay, colleagues? Here, all we're doing is just calculating probabilities. Well, let me give you another information about this question. So, all I can say here is we're just calculating probabilities. That is all. Okay, colleagues? Using a graph. So, this is the graph we'll be using. Our Z-score table. Okay? This graph will be handed to you in the exam. Okay. Now there are two types of graphs. Okay. You just see which place is shaded. Have you seen this blue shaded area? Yes. This is the area to the left graph. So if this is given to you in the exam, I'll teach you how to read both graphs. But today, just keep in mind we're using area to the left graph. Okay. Area to the left. This What this blue region here is representing is just probability. We're saying the area of this graph is the probability. That's all that means. The area of the graph is the probability. Okay. So I'm going to show you how we read these graphs here. Okay. So the first question here is here. We have to find the probability that Z is less than or equal to 3.10. Okay. So take note of the signs, colleagues, and the graphs that you're using. If the sign is pointing to the left, like this graph here, okay, if the sign points to the left, it just means if you're using an area to the left table, you just have to read your value. Just get your value and read. Okay, so here's how we read this graph here. Remember, here is the probability that Z is less than or equal to 3.10. So the first thing you need to do is you need to locate this 3.10 on the table. Have you seen here? Here's an extract of the table. Okay, this is an extract of the table here. Okay, how you read 3.10 on the table? Have you seen, colleagues, this green box here? This represents the first two digits, 3.1. Then the last digit, 0. Have you seen? It's being represented by this 0.00 here. Okay, so you have to get the readings from the column and the top row. Okay, 3.1 here in our column is here. 0.00, it is here on our top row. Then where these two intersect, that is your reading. Have you seen here? 0.990. So your answer for that question is the probability that Z is less than or equal to 3.10 is 0.999. Okay, there's a probability of 99.9% that Z is less than 3.1. Now, they haven't given us context of what Z is and what the 3.1 is, but the probability is 99%. Any questions, colleagues? Mhm. Where did I get? Zero. Okay, here on the table, have you seen if we come to this table? Okay, 0.00. Hello, I can get you, sir. Can you get me? Yes, the 0.00 is here, sir. Have you seen 0.00 top row here? Okay, since it's 3.10, so this zero is represented by that 0.00. Then this 3.1, you're going to find it in this row here. You can see 3.1. Oh, it's just the place value of it, sir. It's just the place value of it. Because, for example, let's say if you have 3.16, it means this last six here is going to be represented by this 0.006. Okay, it's the place value. Okay, if you can see here, 0.06 is the place value that's determining this. If it's 3.14, then you just know that, okay, this 4 here, 0.04. Okay, colleagues, whatever value it is, just know the first two digits, you get them in the column. Then the last digit you get from the top row. Okay. Yes. So this area in blue, colleagues, this area in blue is the 99.99% that we're talking about here. Okay. On this graph here, you find 3.1. 3.1 is here. Should have put there. Then this area in blue is representing the 99.9%. Yes. Yes. Yes, where they intersect. That's how you read these tables. Where these two intersect, the 0.00 and the 3.1, where they intersect, that is your reading. Okay. The next part, Z is greater than or equal to negative 0.27. Now the sign has changed. The sign is pointing this side. It's pointing to the right. Okay. It's pointing to the right. So on our area to the left table, you can see here, it's representing this white region here. Okay, the greater than or equal to. All right, it's representing this white region here. Okay, so this table can only give us this area here. It can't give us the white area here. It's only giving us the area to the left. Okay, think of negative 0.27 here. Negative 0.27 is here. Okay, yes. So we can only get this one, the probability that Z is less than negative 0.27. Our table can only give us this. Okay. So you need to remember this important concept. Probabilities always equal up to 1 or 100%. Okay, you never have a probability of 110% or a probability of 105%. They always add up to 100%, which equals 1. So this area in blue, okay, the area in blue, I'll put it as blue. Area in blue plus area in white should always equal 1. Okay, colleagues? The area in blue, which is the probability that Z is less than or equal to negative 0.21, which is the area in blue, plus the probability that the area in white, which is Z greater than or equal to negative 0.27, should give us 1 when we add these probabilities. Okay, colleagues? The area in blue should plus the area in white, okay, should give us 1. So with this graph, we can only get the area in blue. If it was a graph for area to the right, if we were using the other graph, which is area to the right, you would have just gone to that graph and read the value. Okay, but we're using the area to the left tables here. So we can only get the area to the left. So what we need to do first is we need to get the probability, which is the area, that Z is less than negative 0.27, this one in blue. So remember, colleagues, the first two numbers, you get them in the column. Okay, negative 0.2. Okay, negative 0.2. Then the last number, this 7, is going to be here, 0.07 here. Okay. The first two numbers, you get them in the column here. Then the last number again, get in this top row. So where they intersect, that is our probability. So you bring this down here. Bring this down here. Okay, where they intersect. Okay, that is your area or probability. Okay, so they intersect at 0.3936. 0.3936. So if we come to this, let me put this properly here. Area in blue plus area in white equal 1. So the probability that Z is less than or equal to negative 0.27 plus the probability that Z is greater than negative 0.27 should equal 1. So we've already got this area that Z is less than, we said 0.39. So what it was, 0.3936. Plus, this one we'll call it X, since we want to find this one here, equals 1. Right? So you're going to say X equals, or no, let's not use X, let's just leave the same notation here. Because in the exam, this is how you have to put it, like this. Okay. Plus P Z greater than negative 0.27 equals 1. So want to find this. So we take this 0.3936 over the equal sign. So we say the probability that Z is greater than or equal to negative 0.27 equals 1 minus 0.3936. Okay. 1 minus 0.3936. Okay. So we get our calculators. 1 minus 0.3936. We get 0.6064. The probability is 60.64%. Probability that Z is greater than negative 0.27. Yes. Any questions, colleagues? So this all depends on what table you are using. If it's area to the left, like this table, when you just see in the equation, the sign is pointing like this to the right, then you know that, okay, I'm going to need to get the area to the left and subtract it from 1 to get the area in white. Okay. So this area in white, this is the 0.6064. That's the area in white. Then the 0.393 is this one in blue. 0.3936. Okay, so when you add these probabilities, it has to give you 1 or 100%. Yes. Any questions, colleagues? Before we go to the third scenario. All right, colleagues. So if you see a situation like this, where your Z is between two values, this is what you should just do, okay, colleagues? You get, all you need to do is this: get the area to the left of this and get the area to the left of, basically get the area to the left of both values and subtract them, okay, colleagues? If you see the both signs are pointing to the left, just get the area to the left for both figures and just subtract, okay? So this is how we're going to do it. Okay. This is how we're going to do it. Get the area to the left for both. Okay. We come to our z-scores table. So yeah, let me erase this here. So we start with a smaller one. Say a probability that z is less than or equal to negative 1.45. All right. So remember, the last number is going to be found here, this 0.05. Then the first two numbers, the negative 1.4, we're going to get them here. Negative 1.4 is here. Okay. And then where they intersect, that is our value. So you bring this where there's that 0.05, the negative 1.4, and they intersect at here, point, 0.0735. Okay, 0.0735. So we've got our first one. The probability that Z is less than or equal to negative 1.45. It's a 0.0735. It's 0.0735. Okay. Because as I said, you get the area to the left for both figures. Okay. Negative 1.45 and 2.63. So for 2.63, since it's a positive value, the positive value comes here. Okay. They will let you know this is the positive z-score, and then they will let you know the negative one. So the probability that Z is less than or equal to 2.36. As we said, the last number this 6 here, 0, it comes here, this is 0.06. Then the 2.3, is here. Okay, so where they intersect, where the 0.06 and the 2.3 intersect, you get 0.99909. Okay. So the probability that Z is less than or equal to 2.36 equals 0.9906. Let me make sure that's the case. Is it 9909? Okay. Because in this situation, this case, colleagues, here we're just trying to find the area between 2 points here. Negative 1.45 here, and 2.36 here. Okay. We're trying to find the area in between. That's what we want. Okay. So in that question, when you say probability that negative here 1.45 Z 2.36. Okay. What you write when you're answering this question, so you're going to say it's equal to the probability that Z less than or equal to 2.36. You will see which one has got the higher probability. That's the one you bring in front. It's usually the number to the right which will have the higher probability. Okay. bring in front, minus the probability that z is less than negative 1.45. Oh, I've got the solutions typed out here. Let me see, where is that? Yes. Yes. So it's a 0.9909 minus 0.00735. So 0.9909 minus 0.0735. You get 0.9174. Okay. Or 91.74%. Yes. That's how you deal with whenever they're asking you to find the area between two sides. Okay. When the question comes like this, just remember, okay, if it's both sides are pointing to the left, just get the area to the left for both values and subtract them. Okay, the bigger value first minus the smaller value. Yes. So these are the three main scenarios they can bring for you.